Hi, my name is Elisa Kristina binti Muhammad Munir. My matrix number is 2022858352.
Hi, my name is Nur Hidayah binti Zaid. My matrix number is 2022469092.
Hi, let's get to know what is equilibrium. When a system is in equilibrium, then the outward forces and the downward forces are equal, same as the left and the right forces. Equilibrium refers to a state where an object is balanced, resulting to no movement or motion. This is based on Newton's first law of motion and the principle that an object at rest will remain at rest and an object in uniform motion will continue in that state unless acted upon by an external force. So, why do we need to apply this application? The application of equilibrium principles in elevator systems ensures not only safe and reliable operation, but also efficient energy use and passenger comfort. Other than that, this application helps us to understand stability. Equilibrium helps us understand when systems are stable or unstable. In physics, for example, knowing when an object is in equilibrium tells us if it will remain stationary or move with constant velocity. For instance, engineers and designers carefully consider these principles to create lift systems that operate smoothly under various conditions while prioritizing safety. The benefit of this application is that it is used for safety purpose to ensure structural safety of the lifts to ensure they can withstand loads without collapsing. Overall, applying equilibrium principles enhances our ability to analyze, predict, and control systems, making it a fundamental concept in science, engineering, economics, and beyond. Now, let's get into the problem statement number 1. A lift of mass of 100 kg has two people inside which are 40 kg and 60 kg respectively. The people are lowered to the ground using an inexstable cable attached to the top of the lift. Find the tension of the rope. So let's solve this problem. Firstly, we need to find the way for both passenger and the lift. We can find way by multiplying mass with 9.81. We will get 1079.1 N for passenger weight and 981 N for the lift weight, and the total weight will equal 2060.1 N. Since there's only one cable supporting the lift, tension T will be equal to the total weight, which is 2060.1 N. This calculation ensures that the lift remains in static equilibrium with the outward forces balancing the downward forces.
Now, let's get to problem statement number 2. Given that a lift with a mass of 100 kg has 4 supporting cables and the maximum tension that can be held by each cable is 1960 Newton. If a passenger has the average mass of 60 kg, find the maximum number of passengers allowed on the lift. So first, let's understand the question. So basically, we have a 100 kg lift with 4 supporting cables that can help 1960 Newton maximum tension. And now the question is asking about the maximum number of passengers if the average mass of the passenger is 60 kg. Now, let's get to the solution. First, we will measure the weight of the lift. The formula for the weight is weight equals to mass times gravity. So, the lift weight basically is 100 kg times gravity, which is 9.81. And then we will get 981 Newton. Since the question given gave us the maximum weight for the cable, and there's 4 cables, so we have to times it with 4, which is 1960 times 4, and then we will get 7840 Newton for all of the cable's maximum weight. So now, after we get the maximum weight of the cable, we have to minus the maximum weight for the cables and leave weight to know about the weight left for the passengers. So we will get 9859 Newton. Now 60 times 9.81 to find the weight of the passenger, and then we will get 588.6, and then we will divide 9859 with 588.6 to get the numbers of person that we can put in the lift. So we will get 11.65, and then we will round it up to 11 because 0.65 isn't a person, and we have to ensure that the weight won't go over the limit. To ensure that you guys really understand our topic, we will go through another problem. Problem 3. A lift in a skyscraper has the weight of 500 Newton. The lift is supported by 6 cables, each rated to withstand a maximum tension of 2,200 Newton. If each passenger typically weighs 75 kg, determine the maximum number of passengers that can safely ride the lift at once. So now we will try to understand the question. So now the question given us the weight and not the mass. So we don't have to calculate it anymore. And then this time it's the same question as last time, but the lift now has 6 cables. Now let's get to the solution. So first we will count the max tension of the cable. Since they've given us the max tension for one cable is 2,200 Newton, we just have to times it with 6 for 6 cables, which will equal to 13,200 Newton. And then we count it in kilogram, so we will just have to use the formula weight over gravity equals to mass. So now we will get the mass of 1,346 kg. After that, we wanna find the weight of the lift, so we do the same, and then we will get 50.97 kg, and then we will get 1,296.03 kilogram, and then we will divide it by 75 kilogram to find. Now we will get to the conclusion. Mechanics can be applied to many different aspects of life. Our presentation is just a small example of application of mechanics in real life. Specifically, the application of system in equilibrium in elevator helps engineers design lifts that can safely support their maximum intended load. By carefully balancing the forces acting on the lift, such as the gravitational force on the liftway, the tension in the supporting cable, and the weight of the passengers, the lift can operate smoothly and securely. In conclusion, the application of mechanics, particularly system in equilibrium, plays a pivotal role in the safe and effective operation in lifts. By applying these principles engineers can uphold high standards of safety and reliability, ensuring peace of mind for passengers and operators alike. That's all from us. Thank you.